In this lesson, we're going to have a look at some trigonometric ratios. Now, before we get started with the ratios, let's talk about what is trigonometry, right? Trigonometry is the study of sides and angles of triangles, right? And we explore the relationship between the angles and the side lengths of the triangle. Now, in this chapter, we are going to be focused on right angle triangles. So to start with, right, let's consider a right angle triangle. So I have a right angle given there, and we consider this as a given angle, right? The very first thing we need to do is to label the sides of the right angle triangle, right? And the way we're going to do it is in this format. The side opposite to the right angle, we consider that as the hypotenuse. The side opposite to the given angle, we call that as the opposite side, and the side that is adjacent to the given angle, we call that as the adjacent side. Now, if you're not clear about this, right, as we do more examples, this will become more and more clear. There are three trigonometric ratios that we need to know in this topic, right? The very first one is called sine of an angle, or sine theta equals the opposite side, the length of the opposite side divided by the length of the hypotenuse. Alright, the cos of the angle, which is the second ratio, cos theta equals the length of adjacent side divided by the length of the hypotenuse. And finally, the third ratio, the tangent ratio, tan theta equals the length of opposite side divided by the length of the adjacent side. Right? You might want to rewrite it in a nice crisp format, something like this: sine theta equals the opposite side over hypotenuse, cos theta equals the adjacent side over hypotenuse, and finally the tan theta equals the opposite side over adjacent, right? And like in math, we like to keep things simple. And one of the easiest way to remember all the three ratios is if you remember this word here, SOHCAHTOA, right? So SOH stands for the sine theta equals opposite over hypotenuse, CAH for the cos theta, TOA for the tan theta. So if you remember SOHCAHTOA, it'll be really easy for you to remember all the three trigonometric ratios that we need to know. Now, here's a couple of points about how you're going to find the unknown length of the right angle triangle. That's going to be the focus of our lesson today. In our lesson today, we're going to have a look at the triangles. We're going to try to find the length of an unknown side. Right? I'm not going to read through those 2 points, but we'll apply them in the examples that we're going to look at today. Right, so we're going to solve the unknown length in each of the following right angle triangles, right? The very first step, right? The very first step when it comes to solving a length in the right angle triangle, right, is to label the sides that's been given to us, right? So if I have to label the sides, I've got my hypotenuse, that's my hypotenuse. Now in this question, 70 degrees is my given angle. So the side that is opposite to 70 degrees is the one with the y. So that's going to be my opposite side, and the third side, that's with the length of 5, is going to be my adjacent side in this triangle. Right, now let's go back to this point here. To find an unknown length of a right angle triangle, choose the trigonometric ratios that links one known angle and a known side length with the unknown side length, right? So if I go to this particular question, right, the angle given to me is 70 degrees, right? And one of the sides that I already know is the adjacent side, and I'm trying to find the opposite side, right? So we don't have anything to do with the hypotenuse in this particular question, right? So the ratio that links the opposite side, adjacent side, and an angle is nothing but the tan ratio. So the ratio we're going to pick here is going to be the tan ratio. So tan theta equals opposite over adjacent, right? So I'm going to substitute these values into this particular formula, right? So the value for the angle is 70, so tan 70 equals the opposite side, which is equal to y divided by 5, right? To solve for y, what do we need to do? We need to multiply both sides by 5, right? So if I multiply both sides by 5, right, 5 goes into itself once, right, leaving me with y equals 5 times tan 70 degrees, right? This is where we need to be able to use our calculators, right? So I'm going to go to my CAS calculator here, right? The one thing I want you to first check before you proceed with any of the calculations is the settings in your calculator. So I want you to go to this home page, go to number 5, and then go to number 2, which is document settings. Right, the thing you're looking for is a setting for angle, right? So in my case, the setting for angle is radians, which is not what we want. We want the angles to be set to degrees. So I'm going to change that to degrees. Right, on your calculator somewhere here, there should be a make default button, right? Can I please ask you to go to that and press enter on that? And that way it gets set as a default setting for your calculator, right? So I'm going to go to a new document, right? I want to save this. And I'm going to open up a calculator page, right? So as soon as you do that, you should be able to see that your calculator settings should be in degrees. If it is not, can I suggest you to go back and check your settings again, right? Now, so the calculation we're doing is 5 times. Now all the trigonometric ratios are underneath this trig button here. So I'm going to press the trig button. That gives us all my options. So I'm going to select the tan option because that's the ratio we're dealing with in this question. 70, right? Control enter. Right, so the length of the unknown side in this question, correct to 2 decimal places, is 13.74. So I'm going to go back to this. So y equals 13.74. Right, in this question, there's no mention of any units. So I'm just going to leave it as 13.74. But for whatever reason, let's say if that 5 was 5 centimeters, I will have to write down my answer as y equals 13.74 centimeters. Alrighty folks, right, let's have a look at the second example, right? So we're going to start again by labeling the sides of this triangle, right? So that's going to be my hypotenuse. The angle given to me is 33 degrees, so the side opposite to that is the opposite side, and the side that's adjacent to 33 degrees is going to be adjacent side, right? Second step, we need to pick a ratio, right? We've been given the opposite. We've been given the adjacent side. We're trying to find the opposite side, and we have an angle. So the ratio that relates opposite side and the adjacent side is the tangent ratio. So we're going to pick up the tangent ratio again. So tan theta equals opposite over adjacent. All right, we're going to substitute the values. So tan 33 equals the opposite side is f over 4.3. Right, and again, if I were to solve for f, I want to multiply both sides by 4.3, right? So multiplying both sides by 4.3. So the 4.3 goes into itself once, right? Leaving us with f equals 4.3 times tan 33. So going back to my calculator again, so 4.3 times selecting the tangent ratio, 33. Control enter gives you the answer in a decimal format. So the length of the unknown side is 2.79. So f equals 2.79. Alright, let's have a look at a couple more examples, right, for this particular lesson. So here I have two other triangles, right? I'm going to start with the right hand one, right? See why. Right, so the first step, obviously, we're going to label the sides. So the sides have been labeled as hypotenuse. That's the side opposite to the right angle. Right, the given angle in this question is 35 degrees, and the side opposite to that is going to be my opposite side, and 7 is going to be my adjacent side. Alright, so in this question, right, we've been given the adjacent side, we're trying to find the hypotenuse, and we've been given the angle. So the ratio that relates the adjacent side to the hypotenuse is the cosine ratio. So that's what I'm going to write down first. So cos theta equals the adjacent side over hypotenuse, right? Now let's substitute the values. So cos 35 degrees equals the adjacent side, which is 7, over the hypotenuse, which is 8, which is what we're trying to solve for here. Unlike the previous two examples, right, this time the unknown length is in the denominator, right? So I suggest a very quick step here, right? We're going to swap these two things. Right, if I swap the two, the solving for a is going to be equal to 7 over cos 35 degrees. Right, so now I'm going to go back to my CAS calculator. Right, to create a fraction, I go control divide, gives me a fraction, 7 over, now selecting the trig button, right, this time I'm selecting the cosine ratio, 35 I believe, yep, that is correct, 35, right, control enter, gives me the length as 8.55, correct to 2 decimal places. So the value for a is equal to 8.55, right? So just remember this thing, right? In the first couple of examples we looked at, the unknown variable was in the numerator, right, in both the cases. in the example we just looked at, the unknown variable is in the denominator, right? So you just have to do two different things algebraically. Right, one last example for today. First step, again, label the sides: hypotenuse, opposite, and adjacent, right? So we are trying to find the adjacent side. We've been given the opposite side. The ratio involving opposite and adjacent is the tangent ratio, so tan theta equals opposite over adjacent, right? Substituting values, so tan 45 equals 5.55 divided by x, right? And again, we have a situation where we have the unknown length in the denominator. So what we're gonna do, we're gonna do a quick swap, right? So x equals 5.55 divided by tan 45, right? So if you go ahead and put that in your calculator, you should get the length of x as 5.55, right? And that completes all the examples for today. Thank you for listening. Have a wonderful day.